If you came to a session on disaster recovery planning for Kubernetes, you're in the right room. Presenters today, myself, I'm Steve Wong from Los Angeles. I work for VMware. I'm working on the vSphere cloud provider. I've been active in the storage SIG and other aspects of Kubernetes since 2015. And as part of my career history, I joined VMware when my startup Avamar was acquired, and I worked in the backup field for about 11 years.
I'm Carlisia. I too work at VMware. I came to VMware through the Heptio acquisition recently. And I work on the Velero team. The Velero is a tool that does backup and recovery for Kubernetes clusters, both stateless and stateful apps. And here we are.
So the agenda today, we're going to start with why you need a recovery plan. If I can convince you that you do need one, then we'll get into the elements of what should be in it. Going into details of what you need to back up and why. And finally, we're going to wrap up with a survey of existing tools that will help you do backups and recoveries when running on Kubernetes. And we're going to close with a demo of one of those tools. First, to start out, why you need a recovery plan. Well, people are obviously aware that hardware is never perfect and machines and software fail. In my experience working in the backup field, actually, people like to blame the hardware, but the actual statistics tend to tell you that most of the really ugly scenarios are based on human error, where people make mistakes. You've also got exposure to weather, terrorism, crime, earthquakes, a long list. Depending on your industry, many industries are also faced with conducting backups simply because regulations require them to retain data for certain minimal numbers of years. So the same thing you would do, the same backups that satisfy legal requirements for data retention can be a part of your backup recovery plan. There's a lot of elements of a disaster recovery plan. It isn't all about backups. You need to plan for, in the event of a physical disaster, you need to have made prior arrangements for replacement hardware or replacement public cloud hosting so that you can attempt to stand it up at your recovery site. You also need planning. You don't wait until your system, your data center is on fire and then decide what do we need to get this thing back on the air. A plan in one person's head isn't good enough. You're going to have people who can carry out whatever you've listed in that plan. And finally, those people need to be trained and they need to practice. It's not enough just to make the plan. It has to be a living document. I've heard of places that write this plan, have the disaster 5 years later and discover that so much has changed that it no longer is a viable plan. And it's not enough to document it and keep it on the data center infrastructure you're trying to replace. There's a few ugly stories of people who had an elaborate backup plan, but then they've lost power, lost the data center, and they no longer have access to it. It might be a good idea to actually physically print this out with multiple copies so that you're guaranteed to have access to it, or to keep it on standalone tablets. Tablets are perhaps a little more high-tech than printouts because you can do things like have checklists as you go through a process to try to eliminate mistakes. And that is one thing that I believe the airline industry does now, where the pilots with most commercial airlines keep plans on tablets that the pilots routinely practice with. What do you want to protect? Well, in theory, all native Kubernetes objects are stored in the etcd database. So periodically backing up the etcd cluster is important so that you can recover a Kubernetes cluster. And this statement, I'm not making it up, it's in the Kubernetes docs. The etcd database also is used to hold state for some popular network plugins, not all. There are, the network infrastructure in Kubernetes is a plugin. So Some of those plugins choose to retain their configuration state outside etcd, but many of them are using etcd. The modern trend of extending Kubernetes with CRDs is generally going to hold the state associated with those CRDs in etcd. But there is critical state that isn't in etcd. So etcd isn't going to be enough if you have a total wipeout of a data center. Some things that live outside etcd, persistent volume. So if you're running containerized databases that use persistent volume mounts, the content of those volumes is generally going to be large and obviously not in the etcd key value store. Kubernetes has widespread use of certificates and key pairs, certificate authorities, and if you wipe everything out, if you really want to get a restore and have remote clients attach and get authenticated, you're going to have to restore those certificates. So it's a good idea to keep backups of those available. There are also often going to be service accounts where Kubernetes is running on underlying infrastructure, and that underlying infrastructure or that public cloud is likely to have credentials associated with it. If you have CRDs and CI plugins not using etcd, you need to figure out where that state lives and cover it. Often you're dependent on physical networking infrastructure, things like configuring DNS records, routing, IP assignments. And if you do a rebuild from scratch, you want to record those things so that they can be recovered. Likewise, if you're running on a cloud, a public cloud or private infrastructure, there's very likely to be a bunch of account and configuration status and credentials for that. Redundancy alone is not enough. There are many whose first impression is that, hey, I'm running a 3-node etcd cluster. If I lose one of those nodes, inherently etcd didn't go down. But like I said earlier, the hardware failure isn't the only thing you're protecting against. In a human error scenario, if someone deletes an object and discovers this 5 minutes later, that change will have been replicated more or less immediately to all 3 nodes of your etcd, so you're not going to be able to roll it back. Simple mirroring of what the state is now on multiple things only protects against a subset of the failures you're potentially exposed to. Other things to consider in the realities of your stateful apps are that even your stateless apps, is that these things are based on container images. Now, a rookie mistake might be to be downloading those from Docker Hub, shooting them right into production, but more than likely you're running some sort of private container registry. And if you're recovering from a disaster, you don't want to go figure out what used to be in the old one that's now gone. And even if you did have a list of what images are supposed to be in there, it might take a long time to get those things restored. And even if you pointed to Docker images with particular labels, if you're familiar with how that works, there's no guarantee that the one you had before is actually identical to what's out there with the same label right now. You can put things in Docker Hub with pretty loose labeling. You're not supposed to do it, but labels like latest and whatever, and end up with something non-reproducible. So I'd suggest to you that there are container image registries that are out there capable of replication so that you can replicate them to an outside failure domain, maybe even to another image repository in a cloud or at a distant location, and then count on the replication in the opposite direction to bring things back the way they were originally. Helm charts and maybe other binaries fall into that same category. It may not even be a bad idea to back up any things associated with your hardware, like, I don't know, the base images for OSs, maybe even going so far as firmware updates in case you have replacement hardware that might be sitting there acquired 2 years ago and not have been getting updates. If you have local caches that you maintain every time you download for production, put it in some sort of storage so that if you have to do a recovery or acquire replacement hardware, that this stuff is restorable to the appropriate conditions. You know, there have been stories of people who were running some back level hardware that was no longer out there, so they end up buying replacements off eBay, and there's no telling what kind of firmware updates those might need, and it might be a good idea to set aside storage to hold those kinds of things. So consider a recovery solution for your registries, and maybe replication is a part of that. So the cases for Kubernetes backup solution, I'm going to turn this over to Carlisia.
Hello, I'm back. So when we think about cloud native backup solutions, people usually think of three scenarios. It's either disaster recovery, data archival, or migration. And the tools that are available today, at least as far as we are aware, and tools that are open source at least, are listed on this slide and the following slide. On this slide are tools that do that backup persistent volume. I'm sorry, these tools only back up the Kubernetes objects. And as you would expect, each of these tools, they have different levels of, different sets of features, different levels of support. Like you can see, we added the project contributors. And just as a note, the etcd, that number is not just for the backup feature, it's for the entire etcd, so it's pretty inflated. And on the next slide, we have a list of tools that do stateful app backup as well. And Velero is on both slides because Velero does both. Now, we're going to jump into a demo of Velero, and not coincidentally because I work on the project, so I'm very familiar with that tool. And before I do that, though, I want to give you a visual of a very high-level architecture of Velero. Basically, when you want to back up a cluster, you install Velero on that cluster, and you set up an S3 bucket. Usually, that bucket is going to be on the same cluster, in the same provider as that cluster, but it doesn't have to. It can be in a different provider, it can be on your local machine, it can be anywhere where you can set up an S3 bucket. And when you're going to restore that cluster into another cluster, you install Velero on that second cluster, and you create a restore. Well, first you point Velero to the same S3 bucket, right? Because that's how it's going to get the backup. And that S3 bucket is the source of truth for the cluster. So you point the second cluster to the S3 bucket, and you create a restore, and that will restore the cluster. Now, you can do a full backup or a selective backup. You can do a full restore or a selective restore. Demo time. Big enough? No, thank you. How about this?
Let me move to the back row, I'll check. It's marginal, I might, oops.
More?
I'd go up one more if you can.
You went up 5 more. Is it better?
Yeah, I think at some point you should quit because you won't fit enough on a line.
All right. So before I start with the demo itself, I want to show you what I have going on here. I have a window that is pointing to a cluster that I called development. And I have another window that is pointing to a cluster that is called staging. And you can track by on the bottom here, the orange highlights, you can see as I move through development, staging. Now, how are these clusters set up? They were set up on my local computer, on my local machine, I have 3 systems going on. So if I show you my Docker PS, why is that not showing? Oh yeah, it's up there. Okay, sorry. It's hard to see, but I have a menu container. I have a kind. I'm running a Docker container for kind for the development cluster and another one for the staging cluster. And on this development cluster, if I do kubecontrol get namespace, you see the very bottom one is Velero. So that means Velero is installed in this cluster. Now, if I go to my staging cluster and I do get namespace, you don't see the Velero namespace. It's because it's not installed there. I'm going to install it there later. So let's just deal with this for the moment. I'm going to keep clearing this as I go. Let's see. What do we want to do first? First, I'm going to check if there is any backup in my cluster. None. There's none. All right. Do I want to backup now? No, I don't want to backup now. I want to do something interesting before we create a backup. So what I want to show you is that I have a bunch of scripts because I didn't want you to sit there and waiting for me to mistype things on the terminal. But these scripts are going against these clusters. So it's like it's a real live demonstration, trust me. The first thing I want to do is I'm going to add an app. It is just a named server. So I'm going to run the script to do that. And so I ran kubecontrol get namespace, and you can see the names example from the bottom is the second one. And that is where I have Ning installed. Now, let's see. What I want to do now is run a script that is going to port forward that server. Okay. So it's going to get the name of the node. Okay, seems to be up. I'm going to jump up here, and I'm going to do a curl because I know it's on port 8000. And you see here, welcome to Ning. That means, okay, my server is up and running, and I can keep curling, and you see on the bottom, handling connection, it's all good. Great, so I have a cluster. I have a server running on that cluster. It's live, it's responding. Awesome. I want to check and get pods because, so I'm on the Velero namespace. I'm going to switch to the namespace where I created the Nings server, just so I can type less. So you see the Nings pod running right there. It's ready. It looks great. I'm really happy with this. So now, what do I want to do? Now I want to run a backup because I have something of importance. So the workflow that I'm sort of demonstrating here is I have a development environment, and let's say you have a group of developers and you're building an app, and those developers are pushing to a server, and eventually that app needs to be moved to staging where maybe people are going to test it, and that might happen once a day, multiple times a day, once a week. But the point is that you just take things as is, put it in another cluster, and it's just going to work. And I'm going to show you how to do it with Velero, and I'm going to prove that it really does work. Where was I? Oh, yeah. So now I have something of significance on my cluster. I want to make sure I have a backup, because ultimately that is going to be my migration artifact so that I can transfer to staging. So let's add a backup. That's the command for Velero to add a backup. I'm limiting this backup to the namespace Ning example, which was the namespace that was created with that pod. Now, once you create a backup with Velero, Velero gives a very helpful message saying, well, the backup request was sent. We don't know yet at this point if the backup worked. It could have failed validation. It could have failed to upload to the S3 bucket. But so we have two commands here. One is describe the backup itself, and the other one get the logs only for the backup. So you're not going to see the entire log for the whole cluster, just for what happened to the backup. So I'm going to show both of these commands, the results of those commands. The one that I usually go look at first is this describe, and at the very top you see phase completed, and awesome, that's what I want to see. So it didn't fail. And just for kicks, I'm going to show you what the logs look like. Well, they look beautiful, no errors, great. Now, just for kicks, I'll show you. So I named that backup Acme Dev, and once I list the backups that Velero has for that cluster, it's in there, and the status is completed. Love it. Now, I'm going to go to my staging cluster that, remember, does not have Velero running. And I'm going to show you how easy and quick it is to install Velero. On the fly, right now. Velero install and a bunch of flags that I passed. And I configured this to work with Minio. It takes a secret for the Minio credentials and backup location config. I'm not doing volume snapshots. So I set volume snapshots false. Backup location config, I'm pointing to my Minio system. And here the important thing is this S3 URL that I'm pointing to my local IP number. If I point to localhost, it won't work because Minio is inside a container. My cluster is inside a container. So I point to my localhost, and Minio is running on port 9000, so that is going to work. And, oh, this is cool. So I have an option to push an image, specify the image that I want to push. For example, if I didn't do that, it would try to get the official Velero image, and I don't have access to that. It's stored on the Google repository. But I was able to push my local image, so that is really cool. And the way Velero works is it extends Kubernetes by the use of CRDs. So it creates CRDs for our requests, for restores, for backup, for download requests. RESTec repositories, everything we do is through using CRDs. Okay. So, is Velero running? Let's see. I'm going to do get pods. No, because I'm not on the right. I'm on the default namespace. Get namespace. That's what I want to do. I want to see if the Velero namespace is there. It's there. Great. I'm going to switch to the Velero namespace. Do a get pods. All right, my Velero server is running. Awesome. Do I have backups? Misspelled. I do. How does it know that? Remember when I installed Velero, I configured to point to a Minio instance? That is the same Minio that my first cluster was pointing to. So basically, it's pointing to the same S3 buckets. That's how it knows. Now, from here, so I just to make sure I don't have that NGX example namespace, because why would I? I didn't install the app, right? And I'm not going to install the app either. What I'm going to do is get, so let me see. Add a restore. So I'm going to run the script that's going to create a restore based on that backup that I have. So if you see the command there is Velero restore creates, you can give it a name, or if you don't give it a name, it will generate a name. And I say -- from backup acme dev. And again, it's saying, oh, the request was sent successfully. So that was the request to do the restore. We don't know if the restore worked. Now, so I'm going to do a describe. And up there you can see phase completed. That means it's A-OK. I'm not going to look at the logs. I know it worked. So now I'm going to do get namespace. Oh, look at that. My app is there, looking good. I'm going to come down here now, and I'm going to see if I can boot it. I mean, it's running, it's live, but what I want to do is prove it to you. And I need to see this, so it's not here for me. And I have a different script for this because I need a different port number, because I didn't turn off the number, the port forwarding for my other cluster. So that looks good. I'm going to curl. And this port forwarding that I just created, if you can see on the bottom, is 8100. So, oh my gosh, it works. It's like magic. That's it. A couple more things I want to show you. Thank you. Thank you. Thank you. A couple more things I want to show you that's really cool. All right, so if you're here, I'm going to change directories just so you see you have a clean exit out of this, just make more space. So I'm going to run a script that's going to download the backup. So one really cool thing that Valero gives you is the ability to just, hey, you created a backup on S3, you can download it to your local machine if you want, and that's what I just did. So it's a compressed file. I'm going to show you. It's well, the first one is my script, and the second one is the download itself. And I'm going to untar that, and you see all of your resources there. And if I had backed up a volume, it would be in there too. And I'm going to just expand that a little and show you. And here, right in the middle, oh, not this. Right here is our Nginx pod. Ta-da! And let me just remove this. There was one more thing that I wanted to show you. Yeah, no, I think that's it. Yeah.
Okay, great. We've got 3 more minutes, and I think we have a wrap-up slide with links to this deck, and maybe we have time for a few questions.
If anyone has any question about what I just showed, because I had to go through that really fast, ask me. I also have Valero stickers. And
okay, there's a link to download the deck. Valero is an open source project. It's got a Slack channel on the Kubernetes Slack. There are regularly scheduled community meetings. You can participate remotely by Zoom, and if you can't make it because the time zone's inconvenient, the meetings are recorded and uploaded to YouTube. And there's the GitHub link. So our wrap up here is that I think some of the key points are that there are a number of these solutions, but things like backing up etcd with the built-in backup gives you like all or none. It isn't selective, so you can't choose individual objects or namespaces. Let's just suppose you did one of those full etcds every day. That might be an ugly scenario where somebody makes a mistake on one namespace, and you don't really want to roll it back a whole day and lose the changes that were still good.
And if you're in a managed service, you don't even have access to etcd.
Right. So, you know, some of these solutions work on a more granular basis, and that often is important for some of your disaster use cases. It also can back up more than etcd, capturing the stateful volumes. If you go back in this slide deck, we did link to other open source projects that do parts of this. So I don't mean to overly promote it, but just go look at the facts, the commit rates and the number of contributors to the repository, and go look at that. I think we have time for a few questions, if anybody's got any. Yeah. Do we have a microphone for I'll let you use mine.
Thanks for your presentation. I have two questions. First, how do you back up persistent volume claim? And I think if we can do a backup our volumes, so how can I do such as backup my cluster in AWS and restore in Google Cloud?
Okay, so let me address the first question. Is if you can, we offer native support for AWS, Google Cloud, and Azure, and there are plugins for other providers like DigitalOcean. We have this all documented in our Velero.io website. So just like how do you do that is supported. We have documentation for how to do that.
Yeah, and I think it's fair to say in theory, when you say it supported these, it means that there might be running test cases. But given that this hooks into the Kubernetes API, it should work as a generic solution, right?
No, Velero supports that natively.
Right.
And the way it works is that we use the provider API for those providers that we support. And the plugins that we also have. They use the provider's API to take snapshots, and that's how it gets done. To answer your second question, can you do one from one provider to another provider? You can using Restic, and we have support for Restic. So you install Velero using Restic. You have to annotate the pod that you want to back up that has the volume that you want to back up. So Restic will go through the block system and create a backup, and then you can restore into a different provider.
Is there a means of namespace translation? Let's say if I want to, I could use this, for example, to duplicate a namespace easily. Would this be possible? Let's say that I rename namespace source to namespace target. Yeah,
I think I am not completely 100% sure. You're talking about in the same cluster. Oh, I think so. And we have hooks, pre-hooks and post-hooks that you can use to like annotate and change things. So, and I think one of the things that you can do is change the name of the.
Okay, Carlisia, we ran out of time, and as a courtesy to the next speaker, actually I had hoped to catch the next one myself. We can maybe take questions in the hall, or since this next session seems to be somewhat related to this topic, I'm going to hang around and I'll be available even after the session after this out in the hall. Thank you.